All right, we're looking at something called CPCTC in this section. So for CPCTC, this stands for corresponding parts of congruent triangles. And as you can see, it's going to be an acronym of congruent triangles are congruent. So literally, the CPCTC, C for C, P for P, C for C, T for T, and C for C. This is a reason that we use in proofs, and we only use it after we prove two triangles congruent. So if you notice, most of the time when we've been doing proofs in the past couple sections, we have the given, and then the prove is the two triangles are congruent. So what we want to do is prove the two triangles are congruent, and then our last step will be this for our statement and this right here for our reason. So the last statement and the last reason will be this. The statement before this will be triangle RTQ is congruent to triangle RTS, and we'll have to have a reason. Just to remind you again, the different ways we can prove triangles congruent. We've got side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. The two that don't work are side, side, angle, because that's a backwards donkey, as I tell my class, and angle, angle, angle. Those are the two ways that do not work. Okay? So you need to figure out, you're going to prove the two triangles are congruent using one of these 5 ways. And for this one, I'm looking at angle 1 and angle 2, and I think actually they're kind of extending this out. So angle 1 is right here, and they're extending this out. So angle 2 is right here. So those are congruent, and then we know RTQ, so this angle right here is congruent to this one right here, and RT is congruent to RT since we have two triangles right next to each other. So the two triangles will end up being congruent by angle, angle, side. We just need to prove that this angle right here, RQT, and RST are congruent. And we do that using the congruent supplements theorem. We know that these two angles are equal, so these two have to be equal because they are congruent to supplements. So in other words, if this was 120 and that was 120, both of these would have to be 60. So it's called the congruent supplements theorem. Alright, so we're going to go through the proof for this. We start off by going through the plan again and saying we have to show this first. Once we show this, then we'll know that this is congruent by CPCTC. So we look at this and we say RQT and RTS are congruent, RT and RT are congruent, and when we draw the picture, this is what it's going to look like. And again, we would mark RT as congruent to RT. So we know that these two are congruent, therefore by congruent supplements, those two are congruent, and we have our angle, angle, side. So we're going to use angle, angle, side, and then that proves the two triangles are congruent, and then here's our CPCTC. Okay, gives us QT is congruent to ST. And here's another one. Again, in this case, we look and we say AB is congruent to BC, AD is congruent to DC, and because the two triangles are next to each other, we know that BD is congruent to BD because of reflexive property, sorry. And then the two triangles will be congruent because of side, side, side. Since the two triangles are congruent, we know that angle A and angle C are congruent because of CPCTC. So again, we've got this because it's given, that because it's given. We've got reflexive property for that. and then the two triangles are congruent by side, 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 and finally A and C are congruent because of CPCTC. Okay, and that's it. Thanks.